Have you ever stood at the edge of the ocean, looked out toward the horizon, and wondered why the water looks so deeply blue? It isn't the kind of blue you see in a swimming pool, but something much richer, almost endless. Sometimes it's a bright turquoise near the shore, and other times it's a dark navy that feels both mysterious and powerful. It's one of those everyday sights we grow up seeing, yet we rarely stop to question it. After all, water in a glass is perfectly clear. So, why does the sea transform into this vast blanket of blue? Today, we will explore the science, history, and hidden physics behind why seawater looks blue, and why the answer is more fascinating than you might expect. Long before modern science could explain it, people tried to make sense of the ocean's color through stories, philosophy, and early observation. Ancient Greek thinkers believed the sea reflected the sky, which they saw as a divine blue dome stretching overhead. Sailors in the age of exploration noticed that deeper waters appeared darker and bluer than shallow coastal areas, even when the sky was cloudy, but they didn't know why. In the 19th century, scientists like Lord Rayleigh began laying the groundwork for understanding light and color. However, it wasn't until advances in physics and oceanography in the 20th century that we finally pieced together the real reason seawater appears blue. And the answer turned out to be far more fascinating than simple reflection alone. The most common explanation you'll hear is that the ocean is blue because it reflects the sky. While this sounds logical and reflection does play a small role, it is not the main reason. If reflection were the whole story, the ocean would change color dramatically depending on the weather. But even on overcast days or when fog rolls in, seawater still looks blue. And in places where the sky glows orange at sunset, the ocean doesn't suddenly turn orange across its entire surface. Clearly, something else is happening beneath the waves. To understand the real reason, we need to talk about light. Sunlight may look white, but it's actually made up of many colors, each with different wavelengths. These colors range from red, which has a longer wavelength, to blue and violet, which have much shorter wavelengths. When sunlight reaches the ocean, it begins a completely different interaction. Water absorbs light selectively. Colors like red, orange, and yellow are absorbed very quickly as light travels through seawater. Even within the first few meters below the surface, red light almost completely disappears. This is why underwater photos often look bluish unless artificial light is used. Blue light, on the other hand, has a shorter wavelength and travels much farther through water before being absorbed. As sunlight penetrates the ocean, the blues survive longer than the other colors. But absorption is only part of the story. Scattering is just as important. When blue light moves through seawater, it interacts with water molecules and tiny particles. These interactions cause blue wavelengths to scatter in many directions, including back toward the surface. When that scattered blue light reaches our eyes, the ocean appears blue. In simple terms, seawater keeps the blue and loses the rest. This is why depth matters so much. In shallow coastal waters, you're often seeing light reflect off sand, coral, or rock beneath the surface. White sand reflects more light, which can make shallow water appear turquoise or light green. In deeper parts of the ocean, there's nothing beneath the surface to reflect light back. So the blue we see comes almost entirely from scattering within the water itself. Clarity also plays a major role. In clear, open ocean water, there are fewer particles to interfere with light, so blue wavelengths dominate. That's why remote parts of the Pacific or Atlantic appear so intensely blue. In contrast, coastal areas with lots of sediment or plankton can look green or brown. These particles scatter different wavelengths, changing the color we perceive. Interestingly, scientists can use ocean color to learn about the health of the planet. Satellites monitor changes in ocean color to track phytoplankton blooms, which are critical to global oxygen production. A subtle change from blue to green can indicate biological activity or even pollution. So, the color of the sea isn't just beautiful, it's also informative. You might also wonder why some lakes or rivers don't appear blue at all. Freshwater often contains more organic matter and sediment than the open ocean. These materials absorb and scatter light differently, overpowering the blue wavelengths. That's why many lakes appear green or reddish, depending on their surroundings. So the next time someone says the ocean is blue because it reflects the sky, you'll know the truth is much deeper. Literally, the ocean is blue because water absorbs most colors of sunlight while scattering blue wavelengths back to our eyes. Depth, clarity, and life within the water all work together to create the stunning blues we see from shorelines and space. Thank you for watching. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.